Hello and welcome to this special episode of the Oversteer podcast. My name is Dimitris Bisas. I am your host for the day. And if you're one of our regular listeners, you might be wondering, why does he speak in English? What's the matter with that? Well, the matter with that is that we have a very special guest. Our guest is not Greek. Our guest is American. His name is Bryson Sullivan. He's a graduate student in aerospace engineering. He's an F1 fan, and he's the kind of person you want to talk with about the 2022 regulations and everything technical in F1. The guy just loves talking about that stuff, and I appreciate that very, very much. So, Bryson, welcome, and thank you for coming.
Hello, I'm glad to be here, and thank you for having me.
Well, it's a pleasure because not very often do we have the chance to actually talk with people that know what we're talking about. I don't know what I'm talking about most of the time in the show, so it's good to have a diversity and actually have someone who knows about technical stuff. So Bryson, could you actually point us to when did this love with F1 or even the love with the aerospace engineering field started with you?
Yeah, that is kind of an interesting story, and there are actually two different parts to it. So my father was an engineer and is an airline pilot. And at a young age, I had a love for aircraft. I'm reliably informed that I could tell what type of aircraft was flying in the air from the age of 5, if it was a 737 or a 777. So I did enjoy that. But I also kind of enjoyed cars and motorcycles as well when I was younger. So I really, kind of wanted to do my own thing. I started out an undergraduate in mechanical engineering and really enjoyed, FSAE or, former student, as they have in certain areas, and doing a lot of the mechanical based things. But it wasn't really until I took my first fluid mechanics course, and certainly when I took my first aerodynamics course, that I realized I may have been missing out on my calling. So I took took a graduate level course in gas dynamics and really loved that. And so I had gone to work for a few years, certainly, and then came back, decided to do my master's degree, and that was in aerospace engineering. And right now I'm doing my PhD in aerospace engineering, and I think it's really a cool subject to talk about. What I would say about this particular subject is there are infinite levels to it. However deep you think you've gone into it, there's always another level, always another thing to understand. So it's kind of rewarding in that sense. That's on the engineering side. On the F1 side, believe it or not, my first exposure to F1 was actually the 2005 US Grand Prix.
Oh.
And I know that particular race is famous for being one of the most, if not the most, farcical races in Formula One's history. And I can assure you from being there, it was. What I would say, though, is that it was really my first exposure to actual racing in person. And even though there were a very few number of cars that were actually racing, the performance of the cars stood out. You could still tell that there was something fundamentally different going on here that I'd ever kind of seen before. And so my first real exposure to Formula One was, watching Michael Schumacher in kind of his waning years, but still certainly winning, battling wheel to wheel with Rubens Barrichello for 70 odd laps or whatever it was in Indianapolis. So kind of ever since then, I've been involved in the sport. I've been keeping track of it. But as time has gone on and as I've learned more about the people involved and made new connections, I'm becoming more involved in it, especially on the technical side. And I'm certainly not the smartest person in the room in every situation. I've met the smartest people in the room, so I know. But I think I do have a capacity in most situations to explain things in ways that most people can respond to. I know that F1 technically is of course very complicated, and by all means it should be. But I do think there's something to be said for the democratization of information and sharing it with as many people as possible, because I think all of us share the same passion.
Yeah, absolutely. Because I can attest to that. Many times I had to actually read an article in a more, layman's terms way to actually understand what the fuss is all about on a specific issue or a technical solution that the team had found in the past, and it was controversial and all that. And I'm a journalist. I'm not. I'm not technical person, of course, and that's why I wanted to have you here on the show to talk about the most talked technical issue for the past, I don't know, 4 or 5 years actually, which is the new regulations. Would have been in 2021, of course. It is coming in 2022, the new generation of F1 cars. And even if you're not a graduate student in aerospace engineering, you can see the differences and you can see how they approached the whole new batch of cars. And I have to tell you, Nicolas Tombazis is Greek. I have spoken with him. He's, of course, the technical director of single seater racing in FIA. He's one of the guys that actually made all the tests and tried to figure out how this new approach, or how they should approach, this new generation with the technical team in FIA and F1. And it seems on the outside as a massive undertaking. They talked numbers. They said that the simulations they did were petabytes of data and thousands of years of technical analysis being done by computers, and that's all amazing. But in the viewer, that all has to translate in actual spectacle and closer racing. So, what I want to start with is: do you really believe that this new generation is the most well thought new technical book that we will have, we ever had, in F1? Because they certainly do sell it like that. They say they work for it for the past 7 years.
Yeah, I've heard this question before. There seems to be a lot of people who have reservations about whether or not the engineers are actually going to be able to deliver on their promise of better racing. The one thing I will say about it is this is the first time in my understanding that active CFD simulations were being done not only to simulate the effect of the car in isolation and figuring out what its downforce and drag are in isolation, or even what the impact of the car in front may be, but also this is the first time I've seen people deliberately looking at the effect of their own car on the car behind. Right. And this is, these coupled simulations with multiple vehicles driving in formation, as you can kind of think of. It's really one of the first times I've seen someone do this. And specifically, they've decided to make changes to the design of the vehicle, even if they're sacrificing performance, deliberately to make the cars easier to follow each other. Not only is this evident in terms of the trajectory of the vehicle wake, where they're trying to aim it as it comes off of the car, how turbulent it is, but also the cars themselves, how reliant they are on overbody aerodynamics, so wings and other aspects, and then pushing that more towards underbody aerodynamics and diffusers and venturi tunnels and the like. So the short answer to your question is yes, I do think they will be able to deliver in large part on what they are attempting to do. The only caveat to that is, the FIA is running simulations with their optimal design, with their own set of objective, or at least should say Formula One is running their own simulations with their own design objectives. But the teams have slightly separate objectives. And so what the teams will actually produce will not be quite as optimal as what we were actually seeing in the estimations. I think, if I remember correctly, it's something like you can retain 85% of your downforce at 2 or 3 car lengths back.
Yeah, something like that. 80. Yeah, something like that.
So those are impressive numbers, and I don't think we're going to get quite that high. But at the same time, I don't think we need a crazy improvement to actually improve the racing. So I would, I'm not going to venture precisely what the guess is, maybe 70% or 65 or whatever the actual number is at a given distance downstream. It's going to be better than what we have now. And and we can talk about the details why later, but because it's this understeer of the car falling behind that's really primarily to blame, so to speak, for the issues, it doesn't necessarily need to make a huge change in the flow. As long as you can change the right areas of the flow to improve that particular aspect, I think it'll have knock-on effects that will make things better overall.
Which is, you touched upon a thing that I actually wanted to talk about, because not a lot of people understand that what we saw back in July with the model that F1 presented to us and the teams and the drivers, of course, and they had all these cool photos and stuff like that. It's not the one. It's not the one that we'll see having a different livery next year. It's not like this is gonna be the car, and just imagine it with a McLaren livery or a Ferrari livery or something like that. This is, as you said, way better than I would, the optimal design, the best case scenario, if you will. Or if we want to be not so specific, just their interpretation, just FIA's interpretation, F1's interpretation of how these new regulations will translate on the actual visual of the car, how you see the car, how it's shaped and all that, which is not something that all people do understand. And they have, the fans, and we are fans as well. We talk about aesthetics and all that. Not a lot of people like this new kind of nose or this kind of rear wings and stuff like that. I understand. But it's not like that for all teams. Sure, some teams will have these characteristics and some designs will be the same, but not entirely. It's not a spec series. And I hope you agree with me. We don't go down a spec series route.
Yeah, I definitely do not agree with that. I think, this manufacturer series that we have, is one of Formula One's greatest strengths and also simultaneously one of its greatest weaknesses. And it's precisely this question of what do we want Formula One to be, right? We want to create the preeminent racing series in the world with the most technologically advanced vehicles in the world, racing and competing each other at some of the greatest tracks in the world. And if we're going to do that, you cannot do that fundamentally with a spec series, because what a spec series is, it has a very slow design cycle. You design a car, they race it for a few years, you have an update in a few years, and then you check it again. And that's just a very slow way of iterating on the design, allowing the teams to manufacture their own cars and in fact change them at every single race is the only way to really push the boundaries of what the state of the art is and what it represents at any given time. The downside of that, of course, is that by definition, some people are going to get that more right than others might. And because they're not, because they're not a spec series, some people are going to get it very right and not really be able to compete with other cars just because they went down a design path very early on that they just can't diverge from. So, this question, these are duality of the sport that I think you're kind of hitting on, is that we want it to be the most technologically advanced sport in the world, but simultaneously we also want it to be the greatest spectacle in racing, right? And really those two things are kind of at odds. It takes a special care, a special skill, really, to find a way to meet both of those objectives satisfactorily, at the same time. And I do think that Formula One and, the FIA have done a great job of designing a rule set that teams can work within and still express their, creativity, but it still maintains the spirit of what they're trying to do.
With the new regulations, of course, we have to have in mind that the goal they set was more spectacle, easier overtaking. In fact, they talked about even aborting DRS altogether, which is not going to happen, of course, in the first couple of years, as Ross Brown has said, and Zach Brown touched upon, I believe, during the summer in an interview he did. So we do see that FIA and F1 try to actually have a goal. They try to achieve it. That's what we said yesterday. Earlier, and you touched upon. And you said, "Yeah, let's see how this will pan out," and you believe that it will. But chasing the goal of overtaking and more spectacle in that during that effort, we may have simplified some parts of the car and the designing of the car and the aerodynamics, because you said it better than me. We went on the underbody, we went on the floor. We tried to play with the aerodynamics below the car, and how the pressure of the air is down there, not so much on the surface, which simplifies the design, but actually seems to me, and I want your take on that, to be somewhat restrictive on the designer's minds and sketches.
Yeah, I do hear this concern from people, and my response to it is I don't think it's quite as restrictive as many people's perception is. I'm not saying that it's not restrictive. Of course it is. We can see that. But what I would say is this is especially true in a nonlinear field like aerodynamics, is that small changes to geometry, small changes to design can have massive impacts on integrated things like drag and downforce and other things. And not only that, but the packaging of the mechanical components of the car in the body of a car that has to function as an aerodynamic device also creates some interesting opportunities for ingenuity to express itself. Regarding the floor, if anything, the floor that we have right now is incredibly simplified. And, we can talk about the taking away the edge of the floor and preventing the use of fully enclosed holes and some of those other things. But fundamentally, the bottom of the floor is a flat, completely planar surface with the board underneath to scrape the ground to check wear. The new floor designs are fundamentally different from that. Not only do we have the removal of the barge boards from the front of the car that we currently have, but we have dedicated, highly curved, highly aerodynamic Venturi tunnels underneath the sides of the car that are largely free in many dimensions, and with respect to certain reference planes, they're largely free to the designers to make them however they want. And so even though 2 or 3 designs from different teams may superficially look very similar to first glance, I can tell you from experience that there can be a huge variation in what the designers actually created and the performance that each of them will have. So I do understand this idea that teams are being restricted. They are, but they have freedom in important ways that matter to the performance of the car.
All that has to be translated somehow in terms of actual benefits on track, and that's again we stumble upon the problem that we have with this new generation, that it's here to produce more spectacle, but teams always want to push the boundaries and be a little bit more ahead of the pack, try some ingenious or even slightly above the law and the rules interpretation. I certainly have seen a lot of that on my time. But I mean, what really concerns me, or I don't know if that's the right verb or that's how I can express it in English. I'm sorry. What concerns me so is the fact that all teams will have their own goals, and from what I've read on the technical regulations, and believe me, I try to understand them, as I'm not a techie, nor have I studied that, is that the FIA will clamp down even more on this type of solutions if they believe that they differ a lot or differ at all from their kind of expressing it or designing it or the regulations as they say it. They will clamp down, they will absolutely ban it, which is a bit concerning in terms of, the not only ingenuity, but the innovation. I mean, sure, the F duct in the Ferrari cars back in 2010 was pretty dangerous because they had to leave, the hand from the wheel. Fernando Alonso did that a lot in Catalonia. Yeah, sure, that has to be banned, of course, but there are subtle things that many of us don't know or actually see. And now the FIA will say no to them from the very beginning, from the scrutineering, not even allowing them to raise them. That's a bit concerning. I do want to see innovation, even if we have to divert a bit from the actual goal that is more overtaking and all that, and the 80% more downforce than you would have in these cars and all that. So,
Yeah,
do you
I
agree
was
with
just going to
that?
say, I do hear what you're saying, and again, I think the power of this concern kind of hinges on what the FIA is actually going to do, right? What actually potentially could be different or an offending design that they would quote unquote clamp down on. And I think there might be some distance between what I would interpret them as trying to stop and what the teams may be trying to do. I can't say for sure what they're going to design, but at a minimum, at the end of the day, we're working to the regulations, and the regulations they try to be as specific as possible. I know the engineering jargon can be kind of overwhelming there, and how many hundreds of pages or whatever it's going to be, and radii and all kinds of fun things. But I have to believe that there is a balance that will be struck between what the teams are trying to do and what the FIA is trying to stop them from doing. There's scope for misuse of power in that situation and the stamping out of creativity. But one thing I would say is that the visibility of something like an F duct or a blown exhaust or a flexible wing or any of these things, those are very recognizable engineering sort of achievements. But there are hundreds and thousands of small, tiny decisions that are made in the design of a car and the overall design of a car that ultimately results in a lot of lap time. And there's creativity there in ways that are not as overtly obvious to everyone else, but when you're actually kind of designing the car, all of these things kind of have a cumulative effect to result in a lot of time being gained on the track. And this question of whether something is legal or not, I heard this once and it immediately clicked to me. The sweet spot isn't so much being legal; it's actually being not illegal. But if you think about the distinction there, it kind of gets to what is the spirit of the regulations as they are written versus what's actually in the letter of the regulations. What could you actually do and plausibly claim that you are following the rules? I think that the distinction between those two things is really where so much of the engineering talent is expressed. We'll see. You mentioned DRS. I agree that it's definitely not going anywhere for the immediate future, just in case there's a problem with the new regulations and they need something to help, the cars continue their overtaking. But as I said before, the changes that we've seen, I think, are actually going to work. And in case I hadn't talked about it previously, relying more on the underbody aerodynamics is beneficial because it makes them less sensitive to the cars in front. The actual downforce you can produce has a lower sensitivity to the wake of the car in front if you're doing it with the floor versus if you're doing it with wings. And also, in terms of aerodynamic efficiency, downforce created by the floor is much more efficient. And just to be precise, efficiency really relates to the lift to drag ratio. How much downforce are you making, and what kind of cost are we paying in terms of drag? It's always better to generate downforce with the floor than with the wing. So I do expect things to really be beneficial. I do expect the raceability of the cars to be improved. The question is, how is it going to sort of manifest itself in terms of the actual racing? Can they actually go wheel to wheel? The cars will be slightly heavier next year. They'll have less downforce. What are all these other factors involved in the ways in which cars can interact? Does that result in a show? So I think something's definitely going to happen. I can't predict exactly what it is, but I suspect it will still be entertaining, which is what I think the overarching goal was.
Since we talked technical, and I'll have to, rely on you to actually explain stuff because I can't. Also, excuse the dog that's barking, which is annoying, but I'm not going to exclude that from the final cut. That's for sure. So yeah, I was talking about some explaining you had to do, not in a bad way, of course. You said you talked about lift, to drag ratio. Lift? Why lift? I believe downforce is negative lift. Do we want lift in an F1 car?
Yeah, so I'm a victim of my own engineering mindset. So from an aerodynamics point of view, from an engineering point of view, lift doesn't actually mean opposed to gravity, and it doesn't mean vertical. What lift is a force created by the body and its interaction with air moving over it in a direction that's perpendicular to the direction of motion. Right. So if you have a sailboat, it's got the sail on the top and it's got a keel on the bottom. Both of those aerodynamic and hydrodynamic surfaces are creating lift, even though it's sideways. It's just that lift, I'm talking about lift in the aerodynamic sense, which just means it's perpendicular to the free stream velocity. That being said, when you talk about downforce and you talk about Formula One cars, oftentimes raw numbers in lift are not as useful or interesting as a lift coefficient or a downforce coefficient. Oftentimes in F1, we'll talk about CZ or SCZ, which is, CZ multiplied by S, which is a reference area. Oftentimes that's actually more useful because, fundamental aerodynamics will tell you that the downforce that a car creates depends on the square of the speed. In fact, it's slightly more than the square of the speed because when the car is pressed into the track, the ride height is lower, and that actually increases downforce as well. But roughly speaking, it's proportional to the square of the speed. So if you're trying to test a new aerodynamic package, a new wing, or a new diffuser, or something to test to see how well it's working, and you're measuring raw suspension loads to kind of see how much downforce you're making, you can't actually directly evaluate the performance of your geometry just from those forces. Because what if there's a headwind, or what if there's a tailwind, or a gust? Those things, the raw force is going to change as a function of that, and it has nothing whatsoever to do with the quality of your design.
Even the track surface can play a part of that, of course.
Yes, even the track surface can be. So there's a process. Usually what we are caring more about is lift coefficient or downforce coefficient, which is basically scaling the force by the dynamic pressure times the area, which is basically just accounting for the velocity effect. And it turns out that I'll just briefly say this. It turns out that from an aerodynamics point of view, if you have the same geometry and the same orientation, and you have the same effect of viscosity modeled by a number, you actually get exactly the same lift coefficients. The force coefficients are all exactly the same. You just have to match those numbers. So it actually can be, more beneficial to talk about dimensionless numbers than dimensional ones.
In terms of actually designing a car that has to produce more downforce from the body than it used to, because that's the new mindset of the regulations. Where do you believe are the challenges on the designer's office? Because as far as we are concerned, the normal people that watch F1 and don't have a deep understanding of the aerodynamics, we find it more easily to mingle and play with the surface of the car, because you can put a little winglet there or alter the wing or, stuff like that. How can you play and manipulate with the air from the body, from the underbody, from the floor even? We used to do that in the 80s, of course, with the ground effect and the skirts and all that, which was amazingly dangerous, but also completely cool in terms of watching an old Williams or Ferrari. They were magnificent. But, many people said that was dangerous and so forth. So, twofold question. A, how difficult it is to actually do that. And B, if it's becoming dangerous in a later part of the evolution of the cars.
Yeah, I think so. The things that I would say about that are, at an overall sense, what we're trying to do to create downforce underneath the car is to, or by using the bottom of the car, is to accelerate the flow as fast as possible underneath the car, which will result in the lowest possible pressure underneath it. Just that's an overall idea about what we're trying to do. Maximize the velocity underneath the car. Eventually, that flow has to return to ambient pressure and speed sort of behind the car. And if you can maximize sort of the ratio of how fast the flow is going underneath the car to behind the car, you can really maximize downforce. The problem is, whenever a flow with viscosity slows down, the area diverges in a subsonic flow, the flow slows down, you're having increasing pressure in the streamwise direction. And it turns out that when that change in pressure, you call it pressure gradient, is too steep, is too severe, it will actually cause the flow to separate from various surfaces. This is why when the teams do new testing, they have to put flow visualization paint on things to see if the flow is separating or not. So the overall thing we're trying to do is maximize the velocity underneath the car, which typically requires us to maximize the sort of the deceleration of the flow towards the back of the car and exiting the car, and turn the flow as much as possible without it separating. With the floor, I think fundamentally what you're trying to do, the things that you can do, are change the shape of the venturi tunnels, the contours of the actual bottom, but also, and this hasn't been talked about quite enough, is there are also sort of guide vanes on the front of the floor as well. Not only does the floor sort of curve upwards towards the rear, but it curves upwards towards the front as well. And in that space in the front where it curves upwards, there are some vertical guide vanes that can be used that actually, they don't act quite like barge boards. That's not quite right, but
Yeah.
they are heavily aerodynamically loaded. They do create vortices along their edge, and those do interact positively with the work of the floor. There are other people that are more qualified than me to talk about that, but that's a design area that actually is kind of an unknown at this point, but has the potential for a lot of performance. This question of why is it safer to do this now than it was before? You mentioned this question of sealing the floor and how dangerous some of the cars would be, because, with a physical skirt riding along the ground and physically maintaining a pressure differential, if you lose contact with the surface because of a curb or because the skirt is stuck for some reason, you don't lose a little bit of downforce, right? You lose a ton of downforce, and you lose it in a way that can cause you to crash the car. Why is it more safe now than it was then? The answer I would say to that is because we're not really sealing the floor, right? This claim that we're sealing the floor aerodynamically is kind of a simplification. I think the best way to think of it is there's still flow coming from the outside leaking underneath the floor, but the question is, how easy do you want to make it? Right? How hard is it to have air come from the outside underneath? And again, you don't want that. You want air on the outside of the car to stay on the outside, but because it's low pressure underneath, it tries to suck in. This is one of the reasons why the slots and fully enclosed holes that were in the sides of the floor last year and in years previously were so valuable, is because they create, by their presence, they create a secondary airflow that kind of interacts with the main airflow in a way that the net effect of which is to, partially seal the floor. Again, it's not really sealing it. There's still leakage.
Yeah,
but it preserves the pressure differential a little bit better.
The sealing was, figurative. Of course, you can seal the floor unless you have skirts. And back in the 1980s, they had skirts.
we're not using those physical skirts anymore. And I think the state of aerodynamic design has advanced over time to understand things like pitch sensitivity better, understand things like that, in order to produce a design that is more forgiving in terms of ride height and also vehicle rake. So I don't think it will be anywhere near as dangerous as it was in the past.
Will they be the cars, meaning more unpredictable because they rely on the underbody to produce more downforce? Because this generation from 2017, or if you want 2019, is pretty sensitive in terms of the back end. They tend to oversteer, and when they oversteer, you can't really pick them up again and actually control the back end of the car. You usually end up sideways or even in the barriers. So these new regulations, do they provide cars that are more stable? Are they even more unstable? How do you see it?
Yeah, that's kind of an interesting point. There's actually two things there. One is a question about static weight distribution. How much of the car's weight is sitting on the rear axle versus the front axle when it's just stationary? Another question is aerodynamic sort of center of balance, or you can think of the center of downforce, and how that compares to what that static weight distribution is. You may wonder why it looks like the rear wings are always so much more aggressive than the front wings. There's so much more, turned. Part of that has to do with wanting the center of downforce to kind of approximate the center of mass properties of the car. Because if you can do that, roughly speaking, you can produce a more predictable platform where there's not a huge difference between these two numbers and they're not changing radically as a function of driving condition. As far as the car being difficult to correct in the event of an oversteer, there's not much we can do in terms of the mass distribution. There's just a lot of weight behind the car. The gearbox is maybe not that heavy, but the power unit, and we have the energy store. There are things back there from a mass properties perspective that we just can't really do anything about. But from an aerodynamic perspective, this actually is kind of interesting because if a wing or a vertical stabilizer for an aircraft, you may look at it and say, well, why is it so big? Why is it so wide? Why not use a slimmer cross section and use that to minimize drag for like a 737 or whatever it is? And the reason why a rudder like that has to be so wide is because it has to be able to handle wide angles of attack and still provide some side force to stabilize the aircraft. We don't do that in F1. In F1, as you've seen, our rear wing end plates, so the vertical end plate that end plates that help support the car and minimize induced drag, they're extremely thin. they are incredibly thin to minimize drag, to do their function, but to not have much drag. And what happens is when the car gets in a sliding condition, we call this a yaw angle in engineering terms. What happens is the flow across those end plates, it separates almost immediately, and when the flow is not attached, it doesn't allow the aerodynamic surface to provide a sideways force that could potentially help arrest the slide. That could potentially help, they almost call it like a weather cocking effect. If you've ever heard about that, we had a similar issue with the shark fins, the shark fin engine covers. If you remember that in the 2010, 2011 era,
Yeah.
we had these great shark fins. They were actually reasonably good at actually providing some yaw stability and increasing the tendency to keep the car straight in a small window of side slip angle. But again, the problem is if you get that angle beyond a certain level, that side force doesn't drop off gradually. It drops off aggressively, and the car can just be very difficult to hold on to. As far as the new cars go, if anything, these not quite vertical rear wing end plates and large radius connections to the wing itself may actually be slightly better for handling that and for giving the cars a little bit more margin for their controllability. You may sacrifice something in terms of pure, downforce and how the end plates are working with the wing, or even, aerodynamic drag. I'm not sure. But in terms of the ability for it to maintain some degree of drivability while it's mid-slide, it actually might be slightly better, if only because there may be less flow separation on those end plates when you're in a sliding condition. So my fingers are crossed, but I don't know for sure.
Um, Let me just regroup because I had so many questions as you went through that, and I have to say we have to record for 5 hours to actually get them all, but of course we won't. What I wanted to maybe comment on, and you can expand on it, is the fact that we tend to say drag is bad, downforce is good. Of course, both of them is represent the interaction of the car with the air and the molecules of the air. I am a big fan of Chambers, of Stuart Taylor's. I have interviewed him in the past. He's a lovely chap. He explains a lot of that stuff pretty well, but I tend to be perplexed on stuff like, why do we like, why do we have to make downforce, to produce downforce from the underbody right now in terms just to, not affect the car behind with the wake of the car that we push around the vehicle. But we do like it when it's on the straight. We don't like it when we are, when we turn and maybe we are in a very fast corner where we want downforce to push the car down and actually take the corner more efficiently than, being understeer and actually going off. The fundamental principle is that you do want more air when you are cornering because you want the downforce. When you're in a straight line, the wheel is straight. You go on a straight line. You don't want more downforce than you actually need to actually stay on the ground. But it's a weird balance we have to strike, and I'm not so sure if we strike it by going on the underbody, because when we go to the underbody and actually do that, we eradicate the effect of the slipstream of the toe, or is that something that we'll continue to have but in another way? Do we still enjoy these benefits but also eradicating some of the bad effect on cornering and the downforce on cornering speeds?
Yeah, I think you've touched upon a number of really cool things there. I think the short answer to your question, and then I'll expand on it, is having a. So of course we don't need the downforce in a straight. Both downforce and drag depend on your relative speed through the air, right? You want one and you don't want the other one.
Yeah.
But the thing is, they have to come together. They're a couple. This is why we talk about induced drag, which is a drag that's unavoidable. It's an unavoidable consequence of creating downforce and creating lift.
Well, in Earth, of course.
yeah. But what the floor gets us is actually the drop off that you would see in downforce for a heavily overbody favored aerodynamic package. That drop off is much more when you're following a car in a corner than it would be if you're relying on the floor more. I mentioned that there's an aerodynamic efficiency that the floor creates downforce more efficiently with less drag than the overbody downforce does. But not only that, but it's less effective. The actual air which makes it underneath the car is actually, if you think about it, it's kind of like a small fraction of the overall air that interacts with the car. You think about how small the floor is. Of course, there's streamlines that are converging at the front edge lip to kind of go underneath the floor. But it just turns out that it's easier to maintain your free air downforce levels when you're behind another car with underbody downforce. One thing I would say is that you asked, are we going to lose the aerodynamic toe or the slipstream or anything else like that when we have a more reliance on the floor? And the short answer is no. If anything, it will be even stronger. Your ability to behind a straight, behind another car, your ability to use their aerodynamic toe to make you go faster, if anything, could actually increase because the cars will have less drag overall anyway. I think to help explain why this is, we could just talk briefly about what an aerodynamic toe even is. Like what is a toe? What is a slipstream? And I think a lot of times we talk about punching the hole in the air. We think about this as sort of, pushing air out of the way so that there's less air for you to interact with, right? That's not quite the same thing. So it's true that something has happened in the wake of the car, but it's not so much that air is being pushed out of the way. What's actually happening is that you're driving into a stream of air that itself is following the car in front of you. And it's the relative motion of you and that air that's actually changing your downforce and your drag. I mean, a way to think about this is, if you have an airplane that's taking off, I don't know if you know this, but an aircraft always takes off into a headwind.
Yep, I know.
Right? Aircraft always take off into a headwind because lift and drag depend on your airspeed. They don't depend on your ground speed. And when we think of aerodynamic drag as something that's, pulling the car backwards, by definition, by Newton's, third law, if you want to get into physics, that's also pulling the air forwards behind the car.
Every action has a reaction.
Precisely. In an absolute reference frame, if you're just standing there next to the track and the car flies by you at 300 kph, there's like a 200 kph or something, fast wind immediately behind it. And what's happening is the car behind is driving into that. So even though their ground speed might be exactly the same as the car in front of them, their airspeed is now lower effectively. And I don't want to overgeneralize this because this is a three-dimensional effect and the actual shape and structure of the wake matters. What I see in the 2022 regulations is that the weirdly shaped wing that we are all getting used to, what that does very effectively is it helps to guide the wake upwards, and it helps to draw in air from other sources around the car in a way that don't directly impact the car behind. Because as again, it's really understeer in a corner that's the main problem. If we can fix that, we can do a lot of work. The air that interacts with the wing is actually quite close to the ground initially.
Mm-hmm.
It's interacting with it's quite close to the ground. And if you can take the wake of the car in front and sort of jettison it upward a bit more aggressively, a bit more forcefully, then the actual air which impacts the front wing of the car behind and eventually gets into the floor will have a higher overall energy. So we're not going to lose anything in terms of the overall slipstreaming effects. What I think we're going to get is a better balance of front to rear downforce in a corner behind another car. And I guess the last thing I'll say about that is a lot of the problem that we have with, following cars isn't so much being robbed of raw downforce in terms of raw numbers, like kilonewtons or whatever it is. It's actually the aerodynamic balance of the car. You're still getting tons of downforce on the back end, but now you're not getting hardly as much as on the front end. And, if you think about it aggressively, if you push the rear wing hard enough, the car will kind of pivot around the rear tires and it will try to lift up the front wheels. Right. So even if you had the raw overall downforce level to get the turning, cornering speed that you want, if you don't have the right balance front to rear, it's not going to matter because you don't have the grip where you actually need it. So I think we're going to be in a much better position going forward with the new regulations. Everything that I've seen, both in terms of the official simulations that the FIA is doing and Formula One, but also unofficial simulations that the wonderful people in the F1 community have been running. I've seen some really great results so far, and I think it's gonna work out just fine.
What I took from that statement is that it's not like you push on a slipstream side. It's not like when you're the car in front, you push the air away from the car behind. You streamline it a bit more, so when it hits it, it's a bit more predictable, and actually you can increase your speed because you have less resistance in layman's terms.
Yeah, I think so. The easiest way to think about it is, the forces on the car depend on the velocity, or the aerodynamic forces on the car depend on the velocity of the air relative to the car, right? It doesn't matter what your ground speed is. What matters is your airspeed. It's not so much about organizing the flow. I mean, that's part of it. We're reducing outwash effects and we're cleaning up the bodywork, and that's definitely going to help. But what I would say is, genuinely, if you're driving into air that's already moving away from you, the maximum forces you're going to see are less than they would be if the air was stationary in an absolute sense, right? This has to do with something called stagnation pressure, and this is kind of a aerodynamics point, but Stagnation pressure is just the pressure you would measure if the flow came to rest, in front of an object. It's just a simple idea. But the thing is, that value actually changes in the free stream. It's a very high number, but in the aerodynamic wake of the car in front, that's kind of, taken a lot of the energy out of it, the number is actually less. You have a lower stagnation pressure in the wake of the car in front. So the actual downforce that you can create, it actually depends on the dynamic pressure, which is a slightly different thing, but it depends on the velocity, the relative velocity. The actual downforce you create is going to be lower in any event with the car behind, primarily because of this velocity change effect. The actual pressure field around an F1 car, static pressure, is it high pressure here, low pressure there. That field equalizes to ambient pressure in a relatively short distance, maybe a couple of car lengths or maybe 2 or 3 or at most 4. But that velocity deficit that I mentioned, the slipstream, lasts for so much longer in the flow, because if you think about it, the flow is moving and it has to rely on viscosity to kind of dissipate it and get it back to a slow velocity. This is why we have problems with wake turbulence in airplanes. You have to be miles behind that airplane in front in certain situations. It's not because the pressure field that the aircraft created is still there. It's long gone. It's that there's spinning vortices and there's relative motion and an en masse motion of the air that would cause you a problem, minutes after the fact, potentially. We're seeing that on a smaller scale with the F1 cars.
In terms of 2022, to get back on that and discuss upon it, there is the tire situation and the fact that they're bigger, the fact that the profile is bigger. Of course, that's what I mean. They are 18 inch now, not 13, of course, which is a huge difference in terms of what we were used to, not only visually, but actually technically, and how it will affect the geometry of the car and geometry of the suspension. Of course, F1 cars do have minimal travel on their suspension because lots of the rebound and, the actual stabilization of the car comes from the tire, from the tire itself.
Yes, exactly.
And now we will have bigger profile tires, which I do believe they could potentially disrupt the airflow, and that's why they put on these new flaps above them, or they have removed them now. Are they there?
Yeah, I believe they're still there. We're slightly in a weird situation because we keep seeing concepts of a new car, but when they drove out that, physical model at Silverstone, it looked a little bit weird. So we'll just acknowledge that awkwardness up front and move on from that. The wheels being bigger, going from 13 inch to 18 inch, you're absolutely right that the tires and the tire sidewall of a 13 inch wheel sort of, assembly is very fundamentally different than an 18 inch wheel. The effective stiffness of that part of the suspension is now much stiffer because metal, of course, is stiffer than a pneumatic tire. And so that already is having ramifications for suspension design for the cars. How are you tuning the roll stiffness? How are you tuning the heave? And all these things have to be modified, if for no other reason, purely because the wheels are bigger, number one. Number two, the spinning spokes of a wheel, especially a big wheel, absolutely are a source of aerodynamic disruption, turbulence, and all sorts of things that would interrupt the flow of the car behind. So we are expected to be using wheel covers. I believe it may have been Robert Kubica who first tested the wheel covers on an old Alfa Romeo back in the day at Imola.
Yeah, I do believe so.
Yeah, but at the core, these are designed to kind of contain that disruption and prevent it from escaping sort of the envelope of the car and influencing the car behind. I would also note that we have a sort of a vertical aerodynamic element that it's kind of like as vertical initially on the inside part of the wheel, and it turns to make a right angle over the top of the wheel. That also is an aerodynamic device that's a guide vane that's designed to minimize the front tire wake. One of the reasons why the barge boards are so important is because the front tire wake is a hugely turbulent, low energy, dirty, disruptive structure that you want to get as far away from your nice aerodynamic components as possible. It's one of the reasons why outwash is such a huge thing. It's why we had, the outwash, the inboard loaded front wings and the furniture on top of them before 2018, and all these things that are causing problems for the cars downstream. A lot of it is to do with the front tire wake. And so this new aerodynamic guide vane on the side and on the top of the wheel is designed just to make it a little bit easier for the flow to get around that wheel, to remain attached a little bit longer, and maybe make the wake a little bit smaller. That's definitely going to be a beneficial thing. The one thing that's not reported on as widely, but you've already kind of commented on it, is when you have the bigger wheels, you're also going to have bigger brakes as well. And I don't remember the exact increase in the size of the brake disc, but
it's more mass.
It's bigger. It's bigger for the new wheel than the other one in the previous iteration. So not only are we going to have to consider the pure vehicle performance, aerodynamic aspects of the larger wheels with these wheel covers, but you're also going to have to consider the cooling of the brake ducts, the cooling of the discs. That's a fundamentally different design problem that's being attacked right now. Actually, people are working on doing the simulations right now. Not only computational fluid dynamics, CFD simulations, but also in wind tunnel tests. They actually are doing wind tunnel tests with rolling wheels that actually have the appropriate geometry in the wheel ducts in order to estimate things like mass flow rate and stagnation pressure loss and all these good aerodynamic goodies. But yeah, it's definitely going to be different. It's definitely going to be an engineering challenge to optimize that system. And again, remember, we're operating on our conception of what this is going to actually be based on the models that we've seen from F1 and based on that other thing. What the teams actually decide is best could blow all those things out of the water and completely change our conception of what we're looking at. So I don't know what they're going to do. But I think there's scope there from design creativity.
Yeah, that's what we discussed before, because we said that, of course, every team will have their own iterations of the new regulations, and their cars will, of course, differ from what we've seen from that specific model from FIA and F1. But that may cause some headache on Joe Bauer's head and the scrutineering team at every track. And I believe that the FIA will travel a lot on January from team to team headquarters to actually see what they've been up to and discuss with them. Fun fact, I used to have a friend and interviewee for a couple of times who's Greek and worked in Scuderia Toro Rosso and Alpha Tauri, of course, after the rebranding. He's not there now. He's at Koenigsegg. He's the aerodynamic leader of the company. But he used to tell me how the FIA would come, and check up stuff that would never see the light of an F1 track. And they actually said, no, you can't do that. Or, yeah, you can do that, but you have to change it a little bit and stuff like that. And I'm not talking to you directly right now. I'm talking to our listeners because they may not know that the FIA, of course, does not actually see the cars for the first time when they are unveiled. They see them a lot of times. They see the monocoque on the crash test. They visit the factories to actually check up on stuff, and maybe they've been called from aerodynamicists and the designers to actually get their word on if this thing that they've been working on is actually legal or not, if they should be continuing with that, and so forth. And the most interesting part of it is that's why there was a lot of fuss about Marcin Budkowski and Laurent Mekies, if you remember, Bryson, yourself too, when they were about to leave FIA to actually join a team. And they all said, no, you can't do that because you know a lot of stuff from all the teams. Your job is to do that, actually. So you can't work for a team that, will learn from your invaluable experience, even if you don't have any sort of documents to actually provide to them. You have seen them, you fundamentally understand how they work, and you can actually replicate them. So that's the reason that this fuss is all about. And why I'm saying that is because, of course, you said that the teams will have a profound effect on how these new regulations will work, because they will try to bend and turn and, wheel the whole regulation book on their terms and actually make it theirs as far and as much as they can.
Yeah, I just wanted to say you mentioned the point of Bukowski. I think an even better example may have even been Racing Point with their RP20 in 2020. All of us were shocked, absolutely shocked, to see a Mercedes W10 painted in pink and with a different driver in it.
Yeah.
All of us were kind of scratching our heads. And in fact, the deception was so severe. If you recall, Racing Point did a launch of the RP20 prior to preseason testing, but the car that actually showed up in that launch was not the RP20. It was actually a completely different car. It was a modified version of the old car. In fact, I did a Twitter post talking about it and the boldness of what they did. But essentially, the FIA already knew. Even when they were doing that press conference and showing off their quote unquote new car, as you say, the FIA already knew precisely what they were doing. They had reverse engineered the Mercedes W10 and were going to run with it. It's just the other teams and the public that found out after the fact.
Yeah, of course. FIA knows all but can't tell anything, which is exactly why I wouldn't work with that in that aspect, because I'm a journalist and have to know all and tell all. I cannot shut up about stuff that I do know from the F1 side of things. I don't know what else we could touch on the 2022 regulations. I know that the mirrors are a big aspect. You hate the mirrors. You all hate the mirrors. You want to eradicate them. They disturb the flow of the air more than anything you would like to.
I think if I were to show the average person a direct numerical simulation, fully resolved computer simulation of the flow around a mirror, you would be shocked, absolutely shocked at how much aerodynamic disruption is actually caused by them. It's not just their geometry, it's where they are. They're in a high energy part of the flow. They can take a tremendous amount of energy out of the flow for affecting things downstream. Even the halo has its own aerodynamic characteristics as well. Can't do anything about the halo, can't do anything about the mirrors. The FIA has said where they have to be, so that's where they have to be, and we just move on. Okay, we just move on.
You would imagine that such a technologically advanced sport would have cameras as mirrors, but that wouldn't be practical, of course.
No, that would actually be cool. We've already got cameras in the car. Put cameras on, and then do a heads-up display in the driver's helmet with the rear view direction. That with the camera, that actually could work, and I think it would be a demonstration of Formula One sort of technological prowess to have, instead of physical mirrors, have rear view cameras and project the image into the driver's helmet.
As a Toyota Prius, which is not, which is a 22-year-old car, but we would do it with a helmet HUD. If we did introduce a helmet heads-up display and actually showed not vital points from the car and the measuring and all stuff, but we actually showed the rear view mirror, that would be kind of a bummer, wouldn't it? Because if you can actually project stuff inside of a driver's helmet, you would project, I don't know, maybe the difference from the car behind or, in front of you, and you head up display the mirror. But aerodynamically speaking, of course, having cameras would be very sick. So I'm done with 2022. If you want to say anything more, be my guest. I can't think of anything else we could say in terms of, being relatable and actually people understanding what you say, because that's the main part. You have to democratize, as you've said before, these terms and these complex, of course, models.
The thing that I really want to convey that I think has been impressed upon me even more as time has gone on is every fan base for every sport is unique. Every group of people is sort of slightly different. What I love about the Formula One fan base is how diverse it actually is. Like when you think about the millions of people literally around the world who are all loving the same thing, but also how incredibly knowledgeable they are. I think recently we set up sort of like an F1 technical Discord, a Discord server something that can be used to just have people who are F1 fans, talking about the thing that they love. And we get people that are aerodynamicists. We have, tuning and setup people. We have powertrain people. We have actual journalists that are involved now, and they all have so much information. And I think they are open to talking about it. Number one, which is great, but number two, like they actually know what they're talking about. So I will just say that as I said before, I've been a fan of the sport. I've been an enthusiast of Formula One and motorsports for a long time, but it wasn't until recently that I really gotten a chance to interface with a large fraction of the fan base. And I've just been really impressed with that. And you're, of course, included in that group.
Thank you.
But, I've been very impressed with the work that I've seen being done and the passion for it, not only from the racing side, but from the technological side. It's just been a great few months.
Yeah, it's amazing the fact that you can actually talk with people that know what they're saying, and you have open ears and eyes to get that information and digest it. And it's amazing because I'm not a technical person, of course. I stumbled upon you from various other Twitter peeps, followed you, seen your articles, of course. I will post not only your Twitter handle, which is Natural Paradigm. I will have on the show notes the Discord server, of course. A few articles that I've seen in recent times. You've actually you published a new article on the Italian side, the Formula Uno Tecnica, I believe.
Yes, that was an introductory article about CFD, what it is, what it's not, and why it can be so useful to F1 aerodynamicists.
Yeah, I read it. I understood absolutely nothing, and I said, "Good, this guy knows what he says because I understand nothing." If I don't understand it, means that the guy is actually
no. That means I failed. That means I was trying to make it more accessible.
No. It's fine. I'm not. I have to tell you, in physics, in high school and middle school, I was. I don't know. We have a system from 1 to 20. We don't do A, B, C, D, E, F. In Greece, we do a system from number 1, which is the worst, to number 20, which is the best. I scored 8, 8.5, 7, 7.5 all the time. Ancient Greek, Latin, stuff like that, which is more, theoretical history and all that. I was 2019 in terms of grade. So when I read some of this technical stuff, I try to be open-minded. I heard all this, all the things you said right now on the recording, and I absolutely enjoyed it. And I had so many thoughts and blips and lights that they went off in my head. But it was a great conversation, and I have to conclude it by mentioning something that, of course, we discussed before recording off air, and it is pretty important to me, not on a personal level, because I live in a country that, diversity-wise is not very complex. Most of us are Greeks, most of us are white. We do have a lot of immigrants and people that have been coming from Middle East in the past years, but not so many that actually, make a big difference in the makeup of the country. There are a lot of countries, though, in this world that have a more diverse cultural and ethnicity and color puzzle. There are a lot of countries, as USA is, of course, that have people of color and people that have come and have they are descendants of people from Asia or from Africa, and all these, from even a lot of Greeks in New York, of course. We have a pretty big presence. So I do find it important. I do find it encouraging that in the past couple of years we are forced, but we should have been doing it earlier, but we are forced to actually see the problem and see that the diversity issue in not only F1, but in motorsport in general. I can't point my finger in a lot of drivers or engineers or mechanics that are actually non-white or, not European or not American or Canadian or, stuff like that. Which is by itself not bad, of course. F1 does have the best of the best in terms of drivers and engineers and all that. But I'm sure that a lot of people are misrepresented, underrepresented, I should say, in terms of their potential in F1. I was very happy when I saw Lewis Hamilton bringing up the engineer from Mercedes back in Austria 2020, who I do believe is British but of Indian descent, which is amazing. We saw a woman, not only, a man, not a man, we saw a woman, but also of Indian descent. British people have a lot of these in their country, British and Pakistani people who have been in the country and have been born in that country. America has a lot of people of color. So I'm very happy that I see you being here. Not only because you deserve it in terms of your knowledge, but because you represent a whole new batch of people that have actually been introduced to the sport and have actually a voice in that.
Yeah, I'm extremely happy to be here, and I can't, being a person of color, being a Black person, I can't necessarily take credit for anything that I've done in any specific way because my family has supported me. Many people have been supportive of me and my passion for engineering. What I really love about this sport is there really aren't any limits on passion, right? Everyone loves the same things. We just don't always express it in the same way. Everyone loves, there's something visceral. There's something fundamental about seeing a car on the limit of adhesion at 200 miles an hour that speaks to everyone and encourages everyone to get kind of involved in it. And there are talented people everywhere. I think the challenge with the diversity question goes is just because everyone or several people accomplish the same end goal of getting a degree or getting a job placement, I would argue that doesn't mean they all accomplished exactly the same thing or went through the same travails and the same difficulties to get to that point. I don't know how many people have been actively told by a professor or a teacher that they shouldn't study something because your particular group isn't good at it, right? I don't think people understand the psychological impact that could have on someone who's trying to study something that's hard anyway, and they have a passion for it, and they're probably good at it anyway. But because many people are, they don't, the idea that someone that doesn't look like them could be as good or better than them at something is inherently kind of threatening concept. What I would say is there's no reason to think that. All boats can rise by the same waters, so to speak. I think there's space for everyone. If some jobs are coming up and someone would be getting it that didn't historically have an opportunity to get it, we just need more jobs. The solution is there's more work to be done, and I think all of us can contribute to doing that. I have been extremely impressed with the work that Lewis Hamilton has done specifically in the past few years. Accelerate 25 and the Hamilton Commission and saying something that's not always easy to do, and certainly doing something that is of unknown consequences, right? I mean, any particular person can say something and you have no idea how it's going to be received. So I think for him to do that showed tremendous character and a tremendous commitment to getting the world to reflect its own population slightly better. So what I would do is, number one, try to be the best that I can be, because I know people have been supporting me for quite a long time and the things that I do, but also try to help other people who are trying to break in as well. And I think if we can do that, we can definitely make some changes for the better.
Yeah, I do agree with that. And on what you said, of if someone actually has said to someone, okay, you don't do that because I don't like you doing that. It's not necessary to be like that. So straightforward. Not a lot of girls take up on karting, for example, because it's not a girl thing to do. And I'm air quoting here because you can't see me. No, it's absolutely a girl thing to do. It's a person thing to do. If you're a man or a boy, or if you're, excuse me, or a boy or a girl, it doesn't matter. If you're white or black or Asian, of course, you can do karting if you like it. If you're talented, you'll go and have a career. If you're not talented, you won't have a career.
Right.
So that's the number one issue. I do believe a lot of people don't do stuff not because someone actually actively said them not to do it, just because they believe that the perception, they have a perception for themselves that it's not the thing to do. I don't feel the guilt that I am a white male in a white country in Europe. I feel that I have been extremely lucky to do what I love and not having anyone tell me or make me feel like I don't belong or anything like that. That's how it should have been and is supposed to be for everyone. As it has been for you. You mentioned passion. I do believe in passion. F1 is a passionate sport. It's a technical sport. It's a complicated sport, but on the basis of it all, it requires passion. It requires a lot of talent. It requires a lot of commitment, and that's a thing that doesn't know any boundaries in terms of sex or actual color of the skin. That doesn't matter at all. And I'm all for it, just because I have seen a lot of talented people not being white. I have seen a lot of them. Lewis Hamilton is a 7-time, 100-time winner, 7-time world champion, of course, and he's not white. He represents a whole other part of the population of this world, and that's amazing. So, Bryson, thank you so much for being here. It's been amazing. I've had so much fun. I hope you did too. And I don't know, sign off as you want. What do you want to say for the conclusion of the episode?
Yeah, I would just say I did enjoy being here. As I said before, I am passionate about this sport and about the technical aspects of it. I freely admit to not being the smartest person or the most informed person in this area, but I do like to see as many people as possible understanding things better than they somehow might. So thank you for having me, and I was happy to be here.
So that will do it for this week's episode. It's been the 63rd episode of the Oversteer podcast. We'll catch up again next Monday after the Turkish Grand Prix. I would love to be there. It's 5 hours away from my home where I am right now, but I can't. Alas, I will be at my home and actually enjoy it from the comfort of my sofa, but So thank you so much for listening up until that point. Be sure to follow Oversteer on Spotify, Apple Podcasts, Google Podcasts. Of course, find Bryson in all the links I've left and posted on the show notes. You can find them not only on the podcast platform, but of course on halftone.fm, which is of course the network's website. And we hope that you enjoyed it as much as we did. So until next time, have a great week, and let's enjoy the upcoming Turkish Grand Prix.